Morning.
Morning. How's it going?
Um, good. That assignment was challenging, um, but really helpful to show like how app really works.
Sweet, that's good. I'm glad it was helpful. Today actually is kind of nice because we're going over a lot of data science stuff. So we're not going to be focused too hard on web development. So hopefully we give you guys a break for a second from Flask. We're going to dive in and start making our logistic regression model. All right, so I have the attendance link here. Please go ahead and navigate to that. Is that the right one? Did I send the right attendance link? 1 second. We only have 5 people. We only have 5. Oh, I did? Okay, cool. Sweet. Let me go ahead and share my screen again then. Yeah, so this is the attendance code. I'll wait for everybody to come in. I still need a few more people. But 7391, I'll go ahead and paste that in the chat as well. All right, let's give it a second. Still waiting for a few more people to come in. Seven three nine one. That's the attendance code. Go ahead and paste it in the chat one more time.
Hey, Nick, but before we get started, I had a question I wanted to ask you about common practices.
Yeah, go ahead. What is it?
In terms of tweets, user ID, I kind of felt myself getting a little confused yesterday, trying to refer to one and through the other, trying to problem solve. Is that an issue we're probably going to run into a lot in the industry, just commonly using those terms over and over again, even though they're slightly different?
Yeah, I mean, typically you're going to have multiple indexes, right? So it's just like a good idea to like label them properly. It depends on the context though, because if it's inside of a class and it's an attribute, then it goes with the class. So it's like you don't really need to distinguish the difference. But if it's in the same kind of like variable space, then typically you want to have a different like name, like oh, user ID, tweet ID, and stuff like that. So it's definitely something you run into that's very common, especially if you looked at the RPG database last week. I'm sure you're aware that it was kind of gross, messy, and not fun to deal with. Unfortunately, things in the real world are far worse. That one was bad, but like I can promise you that there's tables that don't even have like their court like informative names. So yeah, it's a bit unfortunate and it can be a bit difficult, but yeah, it's something you're gonna encounter in the real world and especially in the coding space where it's like just having to be able to distinguish between similar-esque variables. Did they answer your question?
Yeah, thank you.
Yeah, of course. Again, just using different variable names and being descriptive with your variable names is a good idea. Again, it's not the worst thing to like have a long variable name. It might seem like kind of annoying, but if you're not using it multiple times, it might be good just to sort of like be very descriptive with your variable names. We do that with SQL. If you saw my SQL variable names, they're kind of long and descriptive, so I knew exactly what they were doing. But yeah, okay. So let's go ahead and see what we're doing with the README today. So today we're going to be adding data science to our web application. And essentially what that's going to look like is we're going to be implementing this linear model, this logistic regression model into our application. And then from there, using the tweet embeddings, the tweet vectors, the sort of, the NLP model that we implemented yesterday through Spacey, we're going to be using that, those 96 numbers to sort of display and train our linear or our logistic regression model. And this will be nice because you can sort of think about it as each user having this profile now, right? Each user has a collection of different tweets stored under the tweets attribute, and this tweets attribute has a collection of different embeddings for each of those tweets, right? So we can sort of get a cadence or a sort of understanding or a model for how each of these sort of users that we enter into our database speaks, and then save that model and use that model to sort of compare the users, right? So ideally, what's going to be happening is we're going to be training a model based on 2 users that we want to compare, and then from that, creating profiles for each of those users, in profiles in terms of, you know, how they tweet using these 96 features that represents each tweet, and then using those profiles to sort of guess who is more likely to say some hypothetical tweet. Now, I mentioned this before, there is some bias that exists within this model. People who tweet more are more likely to be said that they have tweeted this hypothetical tweet. And I encourage you, as a exercise either this weekend or, you know, next week, or when you have free time, or in the future, to sort of maybe try and make the model a bit better, or implement some different types of things. Because this could be a good profile piece if you put a lot of time into it. It's a good profile piece now. Not profile piece, a good portfolio piece now. So maybe you want to add some stuff to it and really personalize it and make it your own, which I encourage, because it's good to have portfolio pieces that show your skills. And yeah, all right. So like you realized yesterday, we have a working web application almost. We still need to add some HTML, some text, and some other things in order to get this fully up and running and be the Twitter model that or Twitter off application that we've seen beforehand. But we're going to add data science today. We've primarily been dealing with web development and database stuff, data engineering stuff. So now we're going to be getting into more data science oriented tasks, such as implementing a model that will, you know, compare users. This is going to be sort of and there's a reason we're using the logistic regression model as well, and we'll sort of get into that, and hopefully it'll, you know, reignite your memory from Unit 2. But the learning objectives for this week or for this day are going to be running and reporting simple online analysis of data from a user or an API. So using API and real-time data in order to sort of run and create a data model. And this is real-time data. If you think about it, when we make a request to that URL, that data might be new. It might be updated, and it might need to be updated. And if you finished the update function yesterday, then you should be aware that these tweets are changing. And when we update the user, when we click update tweets, it should hopefully update all of the tweets of that user. If not, I'll be sharing my code at the end of lesson today, and you can see how I sort of solve that issue. But yeah, the other objective we have for today is to run a more complicated offline model using pickleization and serialization. Pickleization is sort of a modality, or a sort of a form of serialization. It's specific to Python and allows us to store not just models, but objects. And I mean, if you think about it, models in Python are objects, because at the end of the day, everything is an object, right? So Pickle allows us to serialize different objects and then load them up in a different situation. So with serialization, we can offload a model, send it to someone else, or upload it again. And we'll talk about that either today or tomorrow, depending upon time. But before lesson, I hope you have gotten all of the dependencies and accounts you need in order to get everything moving, which means you should start looking at signing up for a Heroku account for tomorrow, because that is what tomorrow is going to be. It's going to be pushing to the cloud, so that our application is not just hosted locally anymore, it's hosted on a server. So other people can make a request to this URL and get back the source code for your website, right? So make sure you have that. And also, hopefully by today, your application should be entirely up and running locally, which means that everything that you, all the functionality that we want and all the functionality that I get to by the end of the day today should be where you are at by the end of day. And that is, again, what the assignment is making sure that you have a completed web application, or at least have completed the task or the steps for today. Because tomorrow, we're not going to be doing any more coding locally. We're just going to be pushing this to Heroku. That's what tomorrow is going to entail. And we're going to add a few more functionalities on the Heroku side as well, such as switching from SQLite to Postgres, which is surprisingly easy. Not easy, but surprisingly simple, more simple than you would expect. So as the assignment, the lesson task, and the objectives, are there any other questions about what's going on? Oh. No, okay, I'm going to go ahead and stop this poll. Again, the attendance code is 7391. Let's stop that. Are there any questions about the stuff we've been doing? No? Okay. So why are we using a logistic regression model? Can anybody explain to me one of the big reasons why logistic regression models are nice and they don't choke? And I can tell you that it ultimately comes down to regularization and efficiency. So let's just think about all of the numbers we currently have, right? We have 96 numbers, and we can have from the API up to 200 tweets. So if you think about it, we have 200 times, we have almost 1,800 data points for each tweet, or for each user that we have. and we have 2 users. So we have a significant number of 18,000 data points. My bad. We have a significant number of data points, right? Which means that it might take a while. And if this is being pushed to, this whole model is being pushed to the cloud, we don't want it to be too hefty or too thick so that it doesn't really work on Heroku. And this is where we get into the offloading of a model where if we do want to have a big model, well, we'll talk about that tomorrow or today, depending upon time. But the reason we're using logistic regression model is because it's pretty basic, and it also applies regularization by default, which means we don't really have to do any EDA or data cleaning. Right, we're not planning on doing any EDA or data cleaning. We're pretty much just throwing numbers into some model. Maybe you could make the model more efficient by doing some type of data cleaning from the process of importing the tweets and then saving them. But it's kind of difficult to do that when we know that we don't really have much intuition about these 96 features that we're generating using Spacey. There's other ways we could clean the data. Maybe we get better profiles, better things, but ultimately at the end of the day, we are going to use logistic regression model because of its regularization and because of its lightness, all right? Now, can anybody tell me what regularization means? I'm gonna go ahead and ask you guys a quick question about it. Okay, what is regularization? Somebody please explain. Standardization of a model's processing flow. I mean more like if we want to regularize the data, what does that do and why do we do it and what does it mean? Regularization I'm talking about in terms of not like a model general processing or workflow, but more in the thing that we apply to the data. When we regularize data, what does it do and why do we do it? Reduce variance in a model. Essentially, yes. So when we do apply regularization, what it essentially does is it sort of shrinks the coefficient estimates towards 0, which sort of cuts back on overfitting the model, right? When we cut back on the coefficients, it sort of takes care of some of the outliers and therefore cuts back on the risk of overfitting. How well the model fits the data, reduce variance in a model with a shrinkage penalty. Yes, exactly. And that shrinkage penalty is applied to the coefficients of the model, right? It just constrains and regularizes them. Now it works to reduce overfitting. Exactly. We do it to help prevent overfitting. Yes, exactly. These are all very good examples of why we perform regularization. And since again, like we're not doing any data cleaning or any exploratory data analysis, it might be nice to have this regularization applied by default. Maybe we want to use some other type of method, maybe some standardization or some type of normalization or some type of, squeezing method. But again, the regularization is going to be nice in this case. I think NLP also handles this regularization. So the spacing model that we were talking about. So we might not have too many crazy values, but it's nice to account for them anyways, just because we're not really even looking at the data. So, all right, cool. So that's why we're using the logistic regression model. We could probably find a better one for sure, but it's just nice to have all of these built in default. So it's also lightweight, which means we're not going to be choking when we actually try and run this model in the web page because we aren't going to be, we're using Heroku's free tier, which is not going to give us much power. And we're also uploading the model directly to Heroku, which also is not the best idea. But again, this is okay. The logistic regression model is lightweight enough that it's not going to be a huge issue. But let's just go ahead and let's start getting into some coding stuff now. So I'm going to go ahead and navigate. But before we move forward, are there any questions about anything? Because we're about to move into actually coding and getting stuff ready and set up. So do any boosters apply relations since logistic model of our classifier? Yes. The logistic, the reason also, yeah, I guess the other reason we're using logistic model is because we're going to be wanting to return a binary value depending upon who is more likely to say the tweet. So we're either going to return a 0 for user 0 or a 1 for user 1, which is nice. The logistic regression model makes that pretty simple. But yes, most boosters apply regularization because they almost need to, right? So yeah, cool. Okay, let's go ahead and navigate to the terminal, and I'm going to go ahead and I'm just in my twit-off-nw dela foo. I'll give you guys a second to navigate there, and we'll go ahead and activate my pip environment, and we're going to install just scikit-learn because that is the model that we're using, right? From the linear models. So we're just going to go ahead and install it by saying pip env install sklearn. You can do sklearn or you could do scikit-learn, whichever you want. The only thing we're installing for today. Okay, give it a moment. And make sure you have all the dependencies that we've been using. You should, considering if you've been following along the last few days, you should be at the same point I am in terms of dependencies you need. Any other questions? Cool. All right. Locking.
So if we're going to improve the logistic model, is it better to have the Heroku paid, or what's, because it's going to slow it down quite a bit if you're adding some, a more robust kind of
Yeah.
ridge regression maybe.
So typically, so you guys will talk about this actually next week. We'll get into sort of ways to have better, more efficient models and how to offload them onto another REST API so that you can just make a request to this API where you are already actually performing the processing. And then once you make that request, you get back your prediction. So instead of what typically happens is instead of, let's say we have a huge model, right? We can either serialize it to share it with people, or we can push that model itself to the cloud and wrap that in an API and create our own API that sort of uses the sort of data science functionality that we are currently just entirely pushing with the application. So as a data scientist, a typical kind of thing that you might want to do is you make the model, you push the model and it's sort of its pipeline to some type of hosted platform such as Heroku. Heroku offers pipelines. We'll talk about that tomorrow. We post it there and then we send data to that pipeline that we made. It handles the data and gives us back whatever prediction or input that we or output that we might want, right? So yes, you would want to use the paid version of Heroku's when it comes to creating a better and stronger model so that they can actually perform, in parallel. Using parallel computing or even Spark does some type of cluster thing for, handling large models. But essentially, yes, you want to get more computer power in order to run more powerful models, right? But since we're dealing with the free version, we are forced to confine ourselves to the logistic regression model. And it looks like there's a dependency that I need. The Google API Python client distribution was not found and is required by the application. All right, let's go ahead and just see what this error is. Probably just need to install that. I'll go ahead and I will answer that question in a moment. I've looked this error up before. Interesting. Probably just need to install. What's the Google API Python client Pippy. Oh, there we go. All right, let's just install this. Hopefully this works. All right. So I can give this a check and then I'll share this with you guys. But let me go ahead and answer that question. I have one question on the or statement on Twitter. Why does it not error out when it gets the information from our database? What do you mean? Why does it not error out? Let me go ahead and open this up in code real quick. It doesn't error out in our database. I guess I don't know exactly which line of code you're mentioning. Would you when I open it up, I can sort of walk you through what's going on exactly. After this is done installing, I'll go to that or thing and we can talk about it. Okay, this is taking a while. But let me just go ahead and walk you through it right now while this is loading, I guess. Go ahead and open up my other terminal and navigate to where I need to go. I got sklearn kind of big, so it makes sense. All right, so let's go to this app dot or the twitter.py where this or statement is located. You can see here I have this db user equals user.query.get user ID or user ID equals user ID name equals username. So this does an error because we're either adding that user to our database here by creating the user, or we're just grabbing him from our database and then we're going to go ahead and add that empty user to our database, which isn't going to do anything, right? Like we're adding nothing to our database, and unless we actually get him, right? Or I mean, so we're either getting the user from our existing database, right? Or we get nothing. And if we get nothing, then it's going to move on to this statement and create that user. And then we're going to add that user to our database. And if we do in fact have him in our database, then we're going to pull him, we're going to assign him equal to DB user, and then we're just going to add him to our database. Now that's going to give us that's going to yes, let me finish. I'm getting to it.
Okay.
That's going to give us that what's nice about SQL Alchemy is it sort of has this built-in thing where if we try to add an existing user, it's not going to error out our entire program. What's going to happen is it's just not going to add them, which is kind of nice. And this is sort of where the updating thing needs to take place is because since we're not updating the user in this DB user statement on line 30, we need to actually go and update them the tweets by themselves. But did that answer your question?
I think so. So what you're essentially saying is, as long as we pulled it from our own database, SQL Alchemy sees it, and when it tries to add it again, it doesn't error out. But if we pull it from a separate database, it will error out because it's not unique.
Yes, it needs to be unique. But if it sees that we're trying to add it, then it sort of just like either replaces the value or it you have to clarify. In this situation, it just doesn't do anything. We can get it to where it updates the user, just the user information. It wouldn't update the tweets because right now we're just adding the actual user himself. We're not adding the tweets like we are when we go to DB tweet. Right now we're just adding the user credentials, and there's really no point in updating them because they're not going to change since Elon Musk ID in the database has been the same ID since its inception. And if he changed his URL, that might be a case where we want to change it. But then we would have an error in the first place because we're passing in a username that doesn't exist anymore because Elon Musk may have changed his handle. And I don't even know if you can change your handle on Twitter. Does that make sense though? Like there's really no point in updating the user information.
Yeah, I understand that, there's no point in updating it, but say we essentially, or something I did for the answer for tweets is I essentially did the same thing for tweets. That way, when it goes through every tweet, it looks to see if there's a tweet there. If there's a tweet there, it grabs it from our database and adds it. But if there's no tweet there, it grabs it from the external database and adds it. And to handle the unique ID, and the part I didn't understand was why, when we grab it from our own database, why wouldn't it give me the unique ID error when it grabs it from an external database and it gives me the unique ID error? If it's basically a SQL Alchemy notices it comes from our own database, then that basically solves the thing.
Essentially, yeah, because this is returning a SQL Alchemy object, right? Like it's coming from SQL Alchemy, and it's sort of like tied to that. Does that make sense?
Yeah.
Okay, cool. Yeah. That's why it doesn't error out, which is nice. I think they added that functionality recently too. It wasn't always that way. But, all right, cool. So let's go ahead and get this downloaded. Let's go ahead and let's now show what we're going to be doing in a new file called predict.py. So I'm going to go ahead and make a file in Twitoff, and we're going to call this file predict.py. All right. So I'm about to show you guys what we're going to be doing in the in predict.py in the REPL. So we're going to just run it through the REPL real quick, show you guys what's happening, and then we're going to do it in the predict.py file. So everything I'm about to code in the REPL, we're going to code again in the predict.py. This is just showing you like the workflow and what we're going to try and do and exposing it to you twice. We go ahead and let's, I already have it open, don't I? So we can see that predict.py is right here just by twitter.py and all the other ones. And I'm just going to go ahead and write a quick docstring and just say that this is a prediction of users based on tweet vector. Cool. All right. So prediction of users based on tweet vectors. Fantastic. I'm just going to leave it like that. And then we're going to go ahead and run into the REPL and just run through a couple examples. So let's go ahead and let's activate. Oh, I already activated our page shell. Let's go ahead and let's enter our shell, our flash shell. I'm going to say flash shell. Remember, I can just say flash shell because of our .env file. Set that equal here. Cool. Okay, I can't find my model. Doesn't new path and factor about Python. Okay, what's that about? That wasn't happening yesterday. App.py, or .py, that's what we want. My model. Maybe I go ahead and do this. Probably not going to do anything, but flash shell can be a bit nifty sometimes. I'm still getting an issue. Oh, is it because I'm in the relative thing?
I actually had to back out the directory one to run mine.
I figured that makes sense because we're referencing the package. But then when I run the Python REPL, it's going to give us an issue. But that's fine. We'll just stay in the flash shell today. So I'll say flash shell. Cool. All right, let's go ahead. Oh, import quit off. Where? The Twitter. Do not import quit off. Dot quit off. Wait. Let's see. End file. If we go ahead and just say flash cap equals quit off flash shell. I'm referencing quit off dot quit off somewhere. App.py. Okay. Well, we're just gonna do this in the Python REPL. Python. Cool. Makes life easier. We're gonna go ahead and say from Twitter off. Oh, I'm in the wrong location. That's why. Gosh. Yeah, I need to be one up. There we go. Fix this. Oops. All right. Flash shell. Oh, that's why. Because I see. Okay. Yep. All right. Bot move. I just realized. I was just in the wrong location, which is why I didn't recognize my model. So we'll just do flash node now. Sweet. Should work. Cool. Look at that. Perfect. Don't change this. Keep it the same. Just make sure you're in the right location. I'm going to go ahead and say from twitoff dot models import user. Import user. And actually, we're going to import DB and tweet. Why not? Import all three. So I'm going to go ahead and say user.query.all to see what we got. We have Elon Musk right now. I'm going to go ahead and add Jack Black. I'm going to go ahead and say from twitoff dot Twitter. Import add or update user. Add or update user. Add Jack Black. Cool. Jack Black is added. Use our query all. We have Jack Black and Elon Musk now. I'm going to grab each of these users and assign them equal to user 0. The user 0, user.query. And we're going to query. I'm going to filter by the username. So I'm going to say user.name and then set that equal to, let's say, Jack Black. All right. Oh, want to be lowercase. That's his name. Set that equal to Jack Black. It is case sensitive. And then we're going to say user1 equal to the user query filter. We're going to say user.name. We want to set that equal to Elon Musk. I'm going to throw a T in here, user.filter. We're going to set it equal to Elon Musk. I'm going to go ahead and do that. And then I'm going to hit enter. And now it's important to note that user 0 is equal to Jack Black. User 0 is equal to Jack Black. And Elon Musk is equal to user 1. So I'm going to say user 1 is equal to Elon Musk. Fantastic. All right, so we have those. I'm just grabbing user 0 and I'm grabbing user 1. I'm going to grab each of their tweets just to see that, to make sure that we do in fact have those tweets. So I'm going to say user 0 dot tweets and then say 0. You can see, oh, tweets. You can see has no attribute tweet. Oh, because I need to pop one. Oops, mistake. I need to go ahead and say user 0, user query dot filter 1, and I need to pop the first one, and I need to do the same thing with user 0. I need to say user 0 equals this, and then dot 1, and then I can go ahead and say user 0 dot tweets. Grab the first tweet. Cool. Looks like it looks good, and then I can grab the user 1 tweets as well, just by saying user 1 dot tweets. Got in the first instance. So it looks like we have all the tweets. Let's go ahead and just check the length of each of these things. So say user 0 dot tweets, 172 tweets by Elon or by Jack Black. And for user 1, we have, see how many tweets. We have 7 tweets. So there's going to be some huge bias here, which is fine. We can figure out how to deal with this later if we wanted. We'll leave it like this for now. I'm going to go ahead and store each of these values as user 0 tweets and user 1 tweets into a list. So I'm just going to go ahead and say, let's also make sure we actually have the vex. So I'm going to say user 0 dot tweets, grab the first instance and then say dot vex because that's the value we had. Dot vex. Let's just double check to make sure that's the right name. Predict.py, app.py, models.py. So we have dot vex. Oh, it's dot vex. So we want dot vex. Cool. Look, we got the numbers that represent the tweets. If I do the same thing for the first one, we can see that we have the NumPy array representing all of the numbers. And I can go ahead and check the type of this just by saying type and thing, showing you that it is in fact a NumPy array. So we are storing these tweets as NumPy array. We're storing these embeddings as NumPy array. That's kind of cool. Now we're going to go ahead and import a couple things. I'm going to go ahead and import NumPy as MP. I'm going to say from sklearn dot linear model, and we want to import logistic regression. We're going to import those two things. Cool. Should take a second. sklearn is kind of big. We know that we have 7 tweets for Elon Musk and 172 for Jack Black. And now I'm going to go ahead and store each of these by saying user 0 vex and then set that equal to the vectors that are found in the user 0 tweet thing. So we want to grab each of the vectors that are associated with each tweet in this tweets list that we have. So I'm going to go ahead and say np.array. All right, and I'll explain this in a moment. This might be a little bit complicated at first, but it's not too bad. So I'm going to say np.array. I'm going to say tweet dot vec for tweet in user 0 dot tweet. All right. So what is this doing? This is going to grab each tweet in user 0 dot tweets. It's a list of 172 tweets for user 0, and it's going to call vect and then save each of those in a list value and then turn that list into an NumPy array. So what we should get back is with user 0 vex is that each index should be the vector of a tweet. So if I do user 0 vex 0, I should get back the first tweet's numbers that represent that tweet text, right? If I do the second one, I should get back the second tweet text that represent the tweet values, right? I'm going to do the same exact thing with user 1. I'm going to say user 1 underscore vex and then set that equal to np.array and then say tweet dot vex for tweet in user 1 dot tweet. Cool. I save that. Now I have user 1 vex. Let's just make sure that this should be of length what? What length should this be? It should be the same length as tweets, right? So there should be 7, right? If I go ahead and check the length, it is in fact 7 because there's 7 vectors that seven NumPy arrays that have 96 numbers that represent each of those 7 tweets, right? The first tweet represents the first number in these user 1 vex. The first list of numbers represents the first tweet in that list of tweets that we were returning, right? Does that make sense?
You're muted.
Yeah. Okay, so we're going to go ahead and move forward. Thank you for that. We're going to go ahead and move forward, and we are going to say, let's go ahead and check out the shape of each of these, say user vex.shape. And we can see that we have 172, 96. So we have these user vectors, they have 172 tweets, 96 features, right? So you can sort of think about it. Each row is a tweet, and each column is a feature that was given to us by this NLP model that we made yesterday, right? And if I go ahead and check out the shape of user one, we can go ahead and see that's going to be 7 by 96 because there's only 7 tweets, but yet there's 96 features that represent each one of those tweets, right? So if I do user one vex dot shape and then hit enter, you can say I have 7 and 96. So 7 rows, 96 features, 172 rows, 96 features. So these are the tweets associated with user 0. These are the tweets associated with user 1. Fantastic. So now I'm going to go ahead and we are going to vertically stack these on top of each other so that we can fit the model to each of these, all 179 of these tweets. But we also need to create our labels. We need to create a corresponding list of labels that we're also going to make by vertically stacking a list of zeros and ones. 0 is going to correspond to Elon, to Jack Black, and 1 is going to correspond to Elon Musk, right? So we're going to have 172 zeros and we're going to have 7 ones. And those are going to be at the same index of the tweets once we vertically stack them. I'll go ahead and show you guys what this is going to look like. I'll just create a list called vex, say np.vstack. It's kind of like concatenation, except it just stacks one list of values on top of the other. So say np.vstack, we're going to say user 0 underscore vex, and then we're going to stack that. We're going to stack that on top of or user 1 vex is going to be stacked beneath user 0 vex. So if I go ahead and enter, and I check out the vex, you can see that for the first instance, I have a user 0 tweet. And then if I do the last instance, you can see I have a user 1 tweet. It doesn't really specify here. There's not like a label attached to them yet. But if we go ahead and take a look at the shape, I can say vex.shape. And we can see that we have 179 tweets because I've stacked these 7 tweets on beneath these 172 tweets. So the last 7 tweets correspond to Elon Musk and the first 172 correspond to Jack Black, right? So that's kind of cool. So now that we know the exact order, we can create some corresponding labels. So I can say labels equals np.concatenate. And then we're going to go ahead and concatenate a list of zeros and a list of ones. And the zeros are going to have 172 zeros, and then we're going to have 7 ones, right? So 172 zeros and 7 ones. So I'm going to go ahead and say np.zeros, and then I'm going to go ahead and we want to make it zeros that are the same length as the number of tweets we have. So I'm going to say length, and then pass in user 0 dot tweets, right? So we're going to get the length of tweets, and then I need to sort of, I need to close it off. Oh, it should be the length. There we go. We're going to make a list of zeros, and then on top of that, we're also going to make a list of ones. So we're just concatenating the zeros on top of the ones. So we're going to have 172 zeros and 7 ones. So I'm going to go ahead and do the same thing except for ones, say np.ones, and then we want the same length of ones as there are user 1 tweets. So just say that. And this will give us back a list of labels. You can see we have 0, 1, and then if we were to look at the length of vex, you would see that we would have 172 vectors or NumPy arrays that represent each tweet. And then at the end, we'd have 7 vectors that represent the user 1 tweet, right? So we have the labels that are corresponding to the same index in this list of NumPy arrays we have, right? So if I go ahead and I now check out the length of labels, we can see that it's going to be 179, right? 179 labels. Fantastic. And now after that, I'm also going to go ahead and create my logistic regression model by saying log reg, set that equal to logistic regression. We're going to set that equal to logistic regression, and I'm going to create an instance of that. And then in the same instance, I'm going to fit this, calling the fit method, and then passing in the vex, which are our x values, and our y's, which are our labels, right? The y's are the value that we are trying to predict, right? In this instance, who said what with the corresponding zeros and ones. Since this is a binary output, right? We're using logistic regression model. And then we are going to pass in the features or the data points that we want to test, right? And each row is a tweet, and each column is a feature or a number that was given to us by the NLP model. All right, so if I go ahead and hit enter, I'm going to have trained my logistic regression model, and I see, check out my log reg. log reg, I can see that I have a logistic regression instance, and then therefore I've created my logistic regression model. Now we're going to go ahead and take a moment. We're going to take a 5-minute break, and when we get back, we're going to go ahead and predict we're going to use this model that we made to predict some hypothetical tweet that we want to make. So we've trained it. It's officially trained. We have our log reg model, and then once we're back, we're going to go ahead and move forward with actually trying to create a prediction, right? Using the log reg.predict method that you guys have probably encountered before. All right, so go ahead and make sure you get an understanding of what's going on. Again, we're going to be doing this in the Python file, but take a 5-minute break. And once we're back, we're going to learn about predicting. So I will see you in a moment. So we're going to go ahead and we are going to run our prediction. So I'm going to go ahead and make a prediction. So let's say log reg dot predict. Okay. And then we passed in some text, right? Wait, that's not going to work because we didn't train the model to run off of text. We trained it to run off of the vectors that we made using vectorized tweet. All right, so how about we go ahead and just save this as hypotext, set that equal to something like Tesla cars, and we're only using like we're not using much to create a profile for Elon Musk or Jack Black. So even something that might be similar that Elon Musk might said, unless they use the same words, we might run into an issue where it's not going to guess the right one. Plus, it's heavily biased. So we're going to go ahead and say that. Then we're going to go say from Twitoff dot Twitter. I'm going to import vectorize tweet. All right, and then when you go ahead and vectorize this tweet, I'm going to say hypotext vect. Let that equal to vectorize tweet, and then pass in the hypothetical text. So I'm going to say hypotext, hit enter. Now we have our hypotext vect. Go ahead and enter. You can see it is now a list of numbers. So we can use this for predictions, right? I'm going to go ahead and say, let's go ahead and check out the length of this. See that it's 96 numbers long. So this is exactly what we need. Now there's an issue we're going to get when we try and pass this into our model. When I say log reg dot predict and I try and pass this list of numbers into our prediction or our logistic regression model, we're going to get back an issue because it is not in the correct format. So if I go ahead and say hypotext vect, you can see we need to reshape it because right now it's sort of a row or it's basically 96 rows. We need it to be 96 columns. So we just need to orient it from this way to this way. Vertical, we need to make it horizontal. We just need to rotate the data because right now we are taking features. There should be 96 features, not 96 single numbers. That doesn't make sense. So we can go ahead and reformat this just by saying, go ahead and say hypotext vect, set that equal to hypotext vect, and then say dot reshape. And you can see that we've gotten that message here. We need to reshape it. So 1 and -1. Cool. And now I can go ahead and pass this in properly, say logreg.predict hypotext tweet, and we should get back either a 0 or a 1. Okay, we got back a 0, and that corresponds to Jack Black. Like I said, there's a heavy bias here. Now, this should also note that this does not include retweets and it does not include retweets, and it does not include responses. So if Elon Musk has responded or retweeted, it's not going to count that. Now, there's this issue as well where there's this back filtering that goes on, and Elon Musk and Jack Black have had a different, it grabs all 200 tweets and then it does this post filtering in the sense where it takes those 200 tweets and excludes all of the replies and all of the retweets, right? So super important, which is why we have 7 tweets for Elon Musk and 172 for Jack Black, because Jack Black has had more tweets and he's had 28 retweets he's had 28 retweets or he's had 28 replies. Elon Musk only has 7 tweets because he has 193 replies or retweets. So this is the API that does this. It's not us, but that's what you should realize is that we are doing this post filtering, which is why we have such little tweets for Elon Musk and so many for Jack Black. All right, so let's go ahead and we got back a 0, so that's our prediction. Let's go ahead and let's now implement this into VS Code. So go to predict.py. We're going to throw this in a module. So what do you remember what we used? We used, let's import numpy as np because we need that vertical stacking and stuff. And we also are going to want to import that sklearn model. So say from sklearn.linear model, import logistic regression. Cool. We're going to import logistic regression. And then we go ahead and import, I'll say from dot models, import user. And we probably also want to say from .twitter, import vectorized tweet, so we can use vectorized tweet. So we're going to go ahead and import that. And I'm going to import the vectorized tweet function, and then so we're going to import vectorized tweet, and then I want you guys to go ahead and see if you can write some of this code now. And then once you've written some of the code, we are going to go ahead and move forward, and I'm going to show you guys exactly what to do. So 2 minutes, try and figure out how you can best implement this. So I'll see you guys when we get back. Okay, so what we're going to do now, so we're going to go ahead and we are going to create a function called predict user. So that's what we're going to do. We're going to say def predict user. And if you had the chance to go ahead and take a look at what we need to do, maybe you would have already started to implement some of the code. So we're going to go ahead and say user 0. We're going to take a user 0 name. All right, we're going to take a user 0 name. We're going to take a user 1 name, and then we're going to take a hypo tweet text. Take a hypothetical tweet text. All right, I'm going to go ahead and say, we're going to give a little doctoring example of what this is going to do. We're going to say determines and returns which user is more likely to say a given tweet. All right, I'm gonna go ahead and full screen this. Say a given tweet. All right, we can go ahead and give a little example of a return statement. I'm gonna say example run, and then we're gonna go ahead and say predict user, and then we're gonna pass in something like Elon Musk. We'll just use the example we used earlier, Jack Black, and like Tesla cars are cool. All right, we go ahead and pass that in, and then what it's going to end up returning, let's say returns either a 0 corresponds to user 0 underscore name, or a 1, which corresponds to user 1 name, right? So that's an example of the run. We can go ahead and now move on to starting to do similar stuff we did to the Python REPL. So I'm gonna go ahead and say user 0, the user 0, and set that equal to query user dot query dot filter. All right. We're going to go ahead and grab that first user with the user.name. So these users have to be inside of our database already. That's important to note. I'm going to set that equal to the username that was initially entered, user 0 underscore name. All right, we're gonna do the same thing, and we're gonna do it for user 1 this time. So I'm gonna go ahead and just copy this. Make sure you edit both the zeros. We're gonna, let's say 1. So we're gonna have user 0 equals user query.filter username equals username 1, and user 1 equals user.query.filter username user 1 name. Okay, so that's all we need to do. And now I'm going to go ahead and grab the vectors from that. We need to go ahead and say .1 though, so we can grab the first instance of that find. All right, so we're finding these users. I'm grabbing users from our DB. Need to exist. Okay, then we're going to go ahead and grab vectors from the tweets attribute. All right, so I'm going to go ahead and say user. I'm going to say user 0 vex. User 0 vex equals np.array. And then we're going to go ahead and say tweet dot vex for tweet in user 0 dot tweet. All right, we're going to do the same thing for user 1. Go ahead and copy this, say user. All right, that makes sense. Oh, I said minus. Oops. Equal. Cool. np.array. So we're making an NP array. That's perfect. Now we're going to want to go ahead and vertically stack the tweets on top of each other by saying vertically stack tweets, tweet vectors on top of each other. Cool. I'm going to go ahead and say user. We're going to say vex equals np.vstack. So np.vstack, and we're going to go ahead and stack user 0 vex and the user 1 vex. So I'm going to go ahead and stack both of those on top of each other. We're going to go ahead and concatenate them by saying user 0 vex and then user 1 vex on top of each other. So I'm going to say user 0 vex. I'm going to say user 1 vex. And then those are going to create a list of vectors. And we did this before. It's going to be in the last situation 172. And then on top of 7 tweets. So we're going to have 179 in total. Okay, so we have vex, then we're going to go ahead and say labels. We're going to set that equal to np.concatenate, and we're going to create a list of labels that are sort of the same length as the vectors that we had. So I'm going to say np.zeros, and then we go ahead and I'm going to say np.zeros, and we're going to want to create a list of zeros so they're the same length as that. So I'm going to say length, and then we're going to want to pass in user 0 dot tweets. So the length of zeros is the same as the number of tweets that we have for user 0, and we're going to do the same thing for the ones just by saying user 1 for np.ones and then saying length and then passing in user 1 dot tweets. All right, we're going to go ahead and create a list of labels. I'll say creating a list of labels the same length as user 0 tweets plus user 1 tweets. Right, so something's going on. Then we're going to go ahead and we're going to add another thing. We're going to go ahead and make our logistic regression model. So I'm going to say log reg equals logistic regression, create an instance of that. And then we want to go ahead and fit it. We want to say dot fit, and then we're going to go ahead and fit it with the vex, and we're going to fit it with the labels. So we're going to say log reg equals logistic regression, dot fit vectors, dot fit labels, or dot fit vex label. Labels are the y's, vex are the x's. Sort of vectors are the features that are associated with each tweet, and the labels are the corresponding labels for each tweet that we have. Then we go ahead and make the typo tweet text and set that equal to the vectorized version of that by saying vectorized tweet. And then we go ahead and say hypo tweet text. Actually make this vect so we can be consistent. Say hypo tweet vect equals vectorized tweet. We'll go ahead and say training, creating instance and training model. Cool. And then I'm going to go ahead and come down here and say creating vectors for hypo tweet, hypothetical tweet parameter. Cool, we've done that, and now we're going to go ahead and we are going to make a prediction. So we're going to say return. I can go ahead and actually say changing. So we can do this all in one. So I'm going to go ahead and say dot reshape because remember we need to reshape it. I'm going to say 1 and -1. Cool. And then I'm going to go ahead and return that prediction by saying log reg dot predict and then passing in that typo tweet back that we made. And then we should get back either a 0 or 1, depending upon who is more likely to say the hypothetical tweet that we passed in. So let's go ahead and give this a test. I'm going to share this code with you guys. So this is the predict.py. Oh, we have that predict.py. Does that make sense? Are there any questions? This is the same thing we've done beforehand. Any questions about what we just did? I'll give you guys a moment just to look over it. Tell me if you find anything that you don't understand or might find confusing. Okay, no questions? All right, let's go ahead and move forward then. I'm going to go ahead and navigate to the terminal, and we're going to go ahead and run this code just to see if it works. We're going to run this function. So I'm going to go ahead and go into Python REPL, and I'm going to, actually, let's do the Flash shell. Let's say Flash shell, and I'm going to say from twitoff.predict import predict user. So we're going to go ahead and import predict user, and then I'm going to say predict. We remember what predict user takes. It takes needs to be log reg. We need to say dot predict, and then we need to pass in the hypo tweet vect. So we can come up here. You can see it takes a user 0. So the first user we want to enter is going to be, let's just say Elon Musk. So Elon Musk. Pass in Jack Black as well. We'll pass in Jack Black. And then we're going to go ahead and also pass in some hypothetical tweet text. So let's just use the example we specified in the doc string. So I'm going to just say, I like Tesla cars. All right. Let's see what happens. We go ahead and enter. We get back a 1. So Jack Black is more likely to say that. We know that's not true because we have human brains. But again, the model is not that perfect. So we need to maybe go ahead and fix that in the future. But it's giving us prediction. So that's really nice. We have a prediction, and now we want to go ahead and actually edit some of this code that we have in app.py. Before I move forward, are there any questions regarding what we've done so far? Nope. Okay, cool. Let's go ahead and go to our app.py. We're going to add a few more things. So I'm going to create a compare route that will compare users. So I'm going to come down to here. I'm going to say I'm going to say add app.route. And then I'm going to go ahead and pass in compare. So we're going to compare these users. So I'm going to say compare. And then we're going to make a function called def compare, and this compare function is just going to compare users. I'm going to go ahead and pass it for now. We're just going to have the compare out there. I'm going to go ahead and get rid of this, insert example users. Leave this like that. I'll go ahead and add this to the additional routes that we have, or the functions that we have. So say base URL compare, and then base URL that, and then come here and say update. Cool. So we have that. We've gone ahead and we've added those doc strings. We added a compare route. Now we want to go ahead and add some additional functionality. So we're going to want to take values from this HTML document that we have. So I'm going to go ahead and say user 0, and I'll show you guys exactly what this is going to be referencing soon enough. I'm going to say sorted. We're going to want to grab request from Flask. I'm going to say request. They sorted, and then I want to pass in a list of values. We're going to say request dot values. And we want to grab the user 0 value, and we want to grab the user 1 value. And this is going to be coming from the HTML document. And I'll show you guys exactly what this is coming from a bit later when we actually make the HTML document, but just know that when the user enters in a value, we're going to be grabbing that from the front end. And the reason we're importing it from Flask is because Flask gives us this option to sort of allow and request values from the front end. All right. And if you remember, when we post those methods, when we add these users to our database, we're going to grab them because they have been posted. So we need to specify that we want to use the post method in this compare route, because that's how we grab these values, is through that post method. They've been posted and we need to request it. All right, so we've gotten those values and we want to go ahead and say if user 0, if those two are similar, if we have the same value, we want to go ahead and return a message saying cannot compare users to themselves. Exclamation point. And then we also want to go ahead and say else. We want to run the prediction if it's not the same user. So we say else prediction equals predict user, because we're importing that from, we need to import that from dot predict import predict user. So we're going to import that and predict user, and then pass in that user 0 value, that user 1 value, and then we also need to grab the hypothetical tweet text that is going to be passed in by the client. We can do this again by saying request.values. So whenever I say request.values, just think that this is coming from the user, and I'll show you how this is coming from the user when we start to code the HTML document. All right, and so then we want to render something. So I'm going to go ahead and we should probably create a message too, saying which user was more likely to be predicted. So I'm going to say message equals, and I'm just going to say is more likely to be said by blank than blank. All right, I'm going to go ahead and format that. Let's say format, and we're just going to go ahead and pass in a conditional statement. So the first thing we want to pass in though is the tweet text, and we can do that again from saying requests dot values tweet text. Cool. And then we can also pass in whether or not it was user 1 or user 0. So say user 1 if prediction else user 0. So remember, we're getting back either a 0 or 1 from this predict user function. So 0 is false, 1 is true, right? So if we get back a 1, and we know that corresponds to user 1 as well, it says request values user 1 if prediction. So user 1 if it's 1 or some other integer value, but we know it's only going to return 1. Else if it's 0, then say that user 0 is more likely to be say it, right? Because this is the second format that's getting filled in. The first one's from request values. Now we're just going to do the exact opposite thing. Say user 0 if prediction else user 1. So we can say this tweet text is more likely to be said by user 1 than by user 0 if the prediction that we get back is 1. The prediction we get back is 0, then we're going to say blank is more likely to be said by user 0 than user 1. So we're just filling in those username. So we're grabbing the username as well, because that's what user 0 and user 1 is. It's the username. Cool. So we're going to go ahead and return a rendered template at the end of this. I want to go ahead and render a new template. We're going to call it prediction.py, which will sort of print out these messages. So I'm going to pass down this message that will get displayed in the HTML document, similar to how I passed down this this users and this title parameter. We can use that variable that we passed down. So I can go ahead and say we want to use the prediction.html document that we have yet to make, and I want the title to be equal to prediction. All right, and then I want the message to be equal to the message that we made. All right, fantastic. So we're going to render that template. I'm going to render that template, and then I'm going to go ahead and create a. I think we're good on that. Yeah, so we're going to go ahead and leave it like that. And then when we get back, we're also going to create a user route, so we can go ahead and edit that. So I'm going to say app.route, and we want to create a user route, and then I'm going to create a function, and we're just going to call this user, and then we're going to create a doc string that just says this is going to redirect us to run this function whenever we visit user. And there's a couple other things we want to use. So we can stack these routes. If we wanted this route to go to, if we wanted reset to be ran with two different routes, we can do that just by saying add app.route and then just passing in another one. So what if we wanted this to be restart instead of reset? So whenever we visit restart or reset, this reset function will ran. So that's how we can stack routes, and we're about to do that with user with multiple parameters. But now we're going to leave it like this. So this is the compare route, and it should be working as intended. We're going to go ahead and take a 5-minute break, and then I'll be sharing the HTML code with you in the Slack channel. So when I do that, please go ahead and copy that and paste that into your base.html. Actually, yeah, let's go ahead and make 2 more files here. Let's make a prediction.html because that's the file that we want to add, or that's the document that we want to go to when we go visit the when we go ahead and visit the compare route. So I'll give you guys a moment. I suggest you look over this compare route during the break, and when we get back, we're going to go ahead and move on to user, and I'll share the base.html with you during this break as well. So see you in a moment. let me go ahead and, all right, so we are going to go ahead and go back to our example, and then we are going to go ahead and finish our user route. So I hope you had the chance to check out the compare route. I shared it in the channel. I'm gonna go ahead and copy this base.html file we have, and we are going to copy it and post it into our base.html file that we have. So go ahead and grab this and navigate here, go ahead and paste it, and then we're gonna go ahead and move this head statement up one. Cool. So all we've really added here is some more information between the block content. So you can see here, I've created this for user statement here, and we can see if we go ahead and run this, I'll show you guys exactly what compare route is talking about when we go ahead and do that request.values thing here with the tweet text and the user 0 and user 1. You can see here that underneath here I have name tweet text, name user 1, name user 0. You can see here that I have gone ahead and made requests of those values through the app.py. So these are requesting the same values that have been prompted here. I'm going to go ahead and run this web page. You can see exactly what this interface looks like. I'm going to go ahead and open up the VS Code. I'm going to go ahead and exit. I'm going to go ahead and clear this up, and I'm going to say Python. We're going to go ahead and say flask run to run the application. Going to be up and running, and got an unexpected argument method. What the heck is it complaining about now? Let's go ahead and see. Clear us. Let me just see this again. Last run. Okay, so we got an unexpected argument method. Where is this complaining about? In main, system argument. Got an unexpected argument method. Okay. Is it? Oh, we got an issue with the decorator method. So we need to go to the app.py. We should probably get rid of this here for a moment. And then we go ahead and run this again, say flask run, and we should be good. Oh, still getting an issue with the unexpected argument method. Because of the post method. It should be methods. That makes sense. Okay, method, not method. Let me go ahead and change that in Slack. There should be methods, not method. Same thing. Simple one, but caught some issues. Cool, go ahead and run it again, and we should be good. Cool. Let's go ahead and copy this. And go to the browser, paste, and then boom. So we have Elon Musk, Jack Black. We got all these new functionalities that we just added with base.html. So let's go ahead and walk through them. If we go to base.html, we can see that underneath this block content, we have a title. So this is again grabbing the same title argument that we're passing down here, home. So you can see we've played home here, and then we have this form action compare method post. This is what the app.py is referencing in the compare method. So if you remember what the action does, what an action does when we complete the forms, when we go ahead and hit compare users, when we submit it here, we hit the compare users value and we enter here, it's going to go ahead and redirect us to the compare route. And it's going to post these values that we've selected. And these values are specified here in user 0, user 1, and in the tweet text value here. So this tweet text value here, you can see is a tweet text to predict, tweet text to predict. This input is corresponding to this input here. And these two drop downs that we have here are only pulling from our current database. So we can see here we have the users that we have. They're only pulling from our current user base, right? When we go ahead and select Jack Black here, that'll be assigned to user 0, and we select Elon Musk for user 1, that'll be assigned to user 1. And then when we hit compare users, we'll be redirected to this route. There'll be some data that has been posted to the browser underneath in memory. When we post this, we can go ahead and we can request those values through our app.py through that request statement that we have here. So request.values, we request the tweet text value that was posted after we've submitted the form. We can also go ahead and request the user 0 and the user 1 values. And I've gone ahead and sorted them so that it's always user 0 and user 1, just a bit of defensive programming. But yeah, so that's what's going on with this. You can also see here we have the options being formatted just by each If you remember, we're submitting users to this base.html. So we have all of the users that are currently existing in our database by this users.query.all. And then we're just going to go and iterate through each of those in our dropdown to show that we have both those two users. We can go ahead and select them, and I can go ahead and pass this in and hit compare users. You can see we get back nothing. I wonder if we're getting back an error, and we get back nothing because we are getting redirected to the prediction.py because this function is being ran. To compare, if you remember, we're rendering the prediction.html template, right? So we haven't coded anything there. So right now we have absolutely nothing in this source code, right? There's absolutely nothing because we're trying to load the prediction.py. Does that make sense? Any questions about any of that? Nope. Cool. All right, let's go ahead and code this user route, and this will allow us to click on a user and display all of their tweets. So I'm going to come down here to user, and we're going to do a few things. And this might be confusing, but I encourage you to stick along until we reference the HTML document again. So I'm going to go ahead and say /user/name, and this name sort of holds as a placeholder for when I want to when I click on them, this name will be pre-populated with the name that I clicked on. So you see here, if I go back, you see that these are highlighted. And when I click on these, it'll redirect me to user Elon Musk. We come to base.html. We can come up here. We can see that when we click on those presented users here, you can see that it is going to redirect me to the endpoint user/user.name. So user, in this case, user.Elon Musk, right? And we want to grab that information, whatever it might be down here. So we're grabbing name, okay? And that method that we're going to use in order to get that name is going to be get, okay? And then we're going to be posting things here as well. This is going to allow us to create new users. Again, this will be a little bit more clear once we actually start to look at the HTML. I'm going to go ahead and make a post method. We're going to say user. We're going to take a couple of arguments here. We're going to say name equals none, and we're going to say message equals nothing. All right, this is just defining the values early on. And once I start coding this, I think this will make a bit more sense, and we can walk through it again. I'm going to say name equals name, or request.values username. Now, if we take a look at this, you can see that this request.values username is referencing this value here. So we have this form, another form, this users form. If we go ahead and take a look at this, we can see that this user form is coming directly from, or is displaying this user form block here. So we have users for user and user. It's going to display the users we have and then allow them to be clicked to redirect them to the route that we're specifying here. Right, and then we have this form that is going to take some text that is going to have the placeholder user to add, and then it's going to have this value username that we can reference once this method has been posted and once this form has been submitted, right? So if we come here, we can see that we have a, once those are added, it will redirect us to this user route, right? The form action, the submission will direct us to the user route, and then it'll have that posted username here. So this username is the one that we want to add to our database. So we're going to go ahead and say name equals name or request.values username. So either we're going to click on this and it's going to redirect us to this route, and it's going to grab the name that is existing here because this none value is just a current placeholder. At some point, when we click on this route, it will evaluate to Elon Musk or Jack Black, and then this will either be Elon Musk or Jack Black. And if it's none, then it's going to continue because this is a conditional or statement, and it's going to remove on to the request.values. So we're going to grab the request.value statement we have here, which is going to be the username that was entered, or it's going to be the username that we clicked on. All right, so this name is going to be either someone that exists in our database or someone that we'd like to add. Then we're going to go ahead and give it a create a try statement to see if the try statement will work. So we're going to say if request.method equals post. So if we are trying to post information and the user has submitted the form, then we are going to go ahead and try and add that user to our database by saying add or update user, which is the function we've imported beforehand. And we are just going to add or update that user in our database. And this will add and update them. So this is going to either, if we have them existing in our database, they're going to be updated, or if they are not in our database, we're going to add them. So then we're also going to go ahead and create a message, and we're going to go ahead and say user, the user successfully added. All right, and we're going to go ahead and format this, say .format, and then pass in name. Cool. So then we're going to go ahead and say that this user has been added to our database, right? And then we're also going to want to go ahead and make an except statement so we don't get that red underline, because every try statement either has to have an except or finally statement. So we're going to say except, and then we want to accept any exception as E, and then we want to go ahead and raise that exception, or we could just go ahead and actually print them out. We can say message. Let's just print it out, the exception error handling blank, and then we'll go ahead and say dot format, and we're going to pass the name and E. All right, so we're going to go ahead and have a message no matter what. User successfully added. We're going to dot format that. Fantastic. What is it complaining about here? Oh, we need to go ahead and see what this is saying. Dot format has unused. Oh, user blank successfully added. Cool. We're missing those curly brackets. We're going to go ahead and if this does succeed, then we're going to want to grab all of the tweets associated with the user and then pass that down to the HTML document we have. So we're going to say tweets equals user.query filter, and then we're going to pass in user.name and set that equal to name, and then say .1, grab the first instance of that, and then we're going to say .tweets. So we're going to say user.query.filter user.name equals name .1 .tweets. We're going to grab all of the tweets from that user. We're going to set that equal to tweets, and then if there is an error and that user already exists in our database or they don't exist at all, then we're going to set that list equal to 0. So tweets is going to be equal to something no matter what. It should be inside of the try statement. Cool. And now after that, we're going to go ahead and we are going to render a template. And this is going to be a different template than the one that we've used. This one's going to be called user.html, right? And we're going to pass down the title of the name of the user that we're trying to reference. We're going to pass down the tweets list, either it's empty or it's full, depending upon if this user is added successfully. And then we're going to go ahead and pass down that message. And we're going to reference all of these different variables in our new user.html file we have here. So I'm going to say new file, user.html. All right, I'm going to go ahead and save that. Our user.html and our predict.html have nothing in it, but our app.py now has a few more routes. Okay, so are there any other questions regarding about what we've done so far before we move on to understanding the HTML documents and deconstructing those? So any questions at all? I'll go ahead and give you guys a second. I'll also share this code with you right now. Cool. All right, so are there any questions about what we just did? I just shared the code with you guys as well, so take a look at that. Cool. Okay, let's go ahead and let's edit our prediction.html and our user.html file. We have our base.html and we're about to learn about HTML inheritance. So let's go ahead and navigate to our prediction.html and our user.html. I'm going to close these other files that we're not even looking at. So this one, and I'll leave all three of these open. So the base.html, what these block contents do is this is sort of for Jinja inheritance, which allows us to basically copy the rest of the stuff that doesn't exist inside these block contents and then exchange information in the user.prediction and user.html and the prediction.html with this block content we have here. So if we're coming to user.html, we can go ahead and we can extend this code. We can say, let's do prediction.html first. We can say, we can extend the base.html and say extends base.html. And what this is going to do, it's basically going to copy all of the code we have here right here, like saying this, besides the stuff that's inside of this block content. So we can go ahead and we can edit the stuff here. And we can basically, this is what this extends base.html is doing. It's copying all of the stuff except for the stuff inside of the block content. And we can go ahead and change the stuff that exists inside of the block content by saying all by saying % block content, and then going ahead and finishing this up and passing in the end block here. So we can say % end block, this will end the block content. And what this is going to look like is this is going to pass all the information we pass in between this is basically going to be passed here and then now be the prediction.html file that we have. So I have that block content. I'm going to go ahead and create a div, and we're going to go ahead and pass in just a basic ID of prediction, and I'm going to hit enter. Just sort of space this out. Cool. So we have that ID. I'm gonna go ahead and create an h2 tag, which just creates a header, and I'm gonna pass in an argument of title. Okay. And I'm also going to pass in a paragraph, and this is being handed down from the app.py. We can go ahead and take a look at that after I'm done with the HTML. We're going to go ahead and then specify that we want this to be a message. And if you remember these curly brackets, this passes down, it takes an argument. So if we look at the prediction.html that is being rendered after the compare route is visited, you can see we pass on a message and a title. So this prediction.html is going to load that title here, load that message here, and then we can go ahead and end that block and leave it like this. This is all we're going to have here for now. Actually, in general, this is all we're going to have. We're not going to add any more to this, but we can go ahead and do the same thing for the user.html. I can extend the base.html, and I'm going to change the stuff between the block content. Again, this is just inheriting directly from the base.html and making this end block content disappear, And we can go ahead and paste in what we'd like to have there. And all we're going to have in there is a div block. We're going to make the ID, we'll just say, the ID is going to be equal to user info, user-info. Cool. And we're going to go have a header here. We're going to have a header here that says h2. And this h2 is just going to be title. And I'm going to go ahead and have a paragraph tag as well, which is going to have that message again. We're just going to say message. Okay, save that. And then we're going to go ahead and leave that div block there. And we're going to create another div block. And this one's going to have the ID of user-tweets. Cool. And then we're going to go ahead and say % for tweet in tweets, another %, and then say span, create a span, set the class equal to vertical stack, which will stack them on top of each other. Cool. And then, or it should just be stack, not be stack. And then we're just going to stack each tweet on top of each other by saying tweet.text, grabbing the tweet text from our database. Cool. From the tweet that we passed in, we're going to go ahead and end this for loop by saying % end for. All right. And then we're going to go ahead and we are going to go back to Chrome and we're going to go ahead and give this a run. So I'm going to come to Flask and X out of this. I'm going to go ahead and say Flask run. I'm going to pull up our web page, pull up the user.html, take a look at this, hit enter. We have our two users. I can go ahead and click on Elon Musk. We get back an error. What's it complaining about? User did not return a valid response. The function returned none or ended with a return statement. So we are running into an issue with user. Let's see what's going on. Because we need to say return render template. I didn't say return. That's important to include. Control C, rerun, go back to this, and we'll go ahead and we will revisit this link. Cool. Go ahead and click Elon Musk. Cool. We got all of Elon Musk tweets here. Maybe we can wrap this in quotations. All right, if we go back to quit off, just by clicking the home button, we go to Jack Black. We can see we have all of Jack Black's tweets listed as well. Cool. I can go ahead and try and add a user like Hillary Clinton, add her, see if that works. Boom, we've added Hillary Clinton. All of Hillary Clinton's tweets are there. If we come back, we can see that Hillary Clinton is now part of our database. We can click Hillary Clinton, look up a thing. It says, let's send Tesla to Venus, go songs. It's more likely to be said by Hillary Clinton than Elon Musk. Again, bias, if we try and compare Jack Black and Elon Musk, though, or Jack Black and Hillary Clinton, it seems like they have similar number of tweets. And we say, rock a podcast I think he does podcast now and Tenacious D or something. We can go ahead and see if we get back Jack Black. It's more likely said by Hillary Clinton than Jack Black. Okay, so it's clear we have some bias. I don't really know what Jack Black tweets about anymore, but maybe that is more likely to be said by Hillary Clinton, at least in terms of a model. We also have our menu up here. I can go ahead and reset the database. The DB has been reset. Maybe we, instead of just resetting, we want to go to our app.py, and instead we want to, you know, instead we want to render a different template here. But we just want to render the home screen template. Go ahead. All right, cool. So it looks like it's working as intended though. If we go back to the regular route, we can see that all of our users are now gone. We don't have them anymore. If I wanted to add Elon Musk again, click add Elon Musk, go back to home screen, and you can see Elon Musk is now there. Elon Musk is in our database. His most recent tweets. Looks like he's tweeted a lot more recently. Cool. And if we go ahead and try and compare users to themselves, cannot compare users to themselves. So you see we have a up and running application. It looks like it's working as intended. Are there any questions about what we've done? I'm gonna go ahead and share this app.py with you guys once more. And then I want you guys to we're gonna take another 5-minute break. And when we get back, I want you guys to shoot any questions you have at me, because the assignment today is making sure that you are on the same page. Go ahead and comment out this thing right here. But I want you guys to take a second and really dissect the application we've built so far. I have all the pieces of code in here. I'll show the HTML and the prediction right now, the prediction, the user.html right now, just so you guys can take a look at it. But if there's anything you need me to explain, please, 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 please ask, because we have a few minutes at the end of class to sort of go over anything that might be too confusing. I know I've moved pretty quick the last few days, but that is unfortunately the nature of this week. So again, we have time to go over any questions you might have. So we're gonna go ahead and take another 5-minute break, formulate some questions you might think you have, and examine the stuff you see here, play around with the application, and see if there's anything that does not make any sense. It should be up and running. Things should be working. I'll go ahead and start that timer, and if you have any questions, please ask. Okay, are there any questions about what's going on? No questions, guys? This all makes sense. Everything I did makes sense. Again, you guys have time after lesson today in order to get an understanding of what some of the nuances you might not understand. But is there any questions about anything at all? Okay, well, let's go ahead and let's see. Oh, let's see if this update route works. All right, let's troubleshoot why this is not working. So let's go ahead and take a look at our terminal. From non-decoder, just expecting value line 1, column 1. Okay, so we're running into an issue with the update function. Like a couple of you guys said earlier, for app.py, we need to adjust the, what is it? Figure out how to properly update users when the update route is visited. So we want to go ahead and maybe instead of go ahead and grab the DB user thing, do DB tweet. In fact, actually, I'm thinking about leaving this for you guys as a stretch goal, just in case today's time it might be a bit easier. Not a stretch goal, but as maybe giving you guys more time to work on it. I'll go ahead and push my code by like 2 or 3 p.m. today with the solution to it. But if you haven't figured it out yet, maybe spend some time trying to figure it out, because I think this is a valuable exercise. And considering most of the assignments this week have been you following along and making sure you're on the same page, might be useful to do something that is a little bit more challenging. So instead, I'm going to actually leave this as a to-do for you guys. And when this afternoon pulls around, I'll go ahead and push the updates and let you guys know about that. If there's no questions, then we might save 15 minutes and move forward. But is there really nothing that you guys are confused about? I will 100% explain anything that does not make any sense at this moment or in the next 15 minutes. Okay, I will let you guys have 13 minutes then. Enjoy an early lunch. Any questions about the assignment or anything, please feel free to reach out. Again, office hours today, so hopefully I see you there. All right. Bye, guys.